They're saying lists the members of set P and T. Now, who can help us do that? What are the elements of set? What are the elements of set P? They're saying P, all prime numbers less than 10. Jerome, can you tell us what those elements are? P will be a set of, what are the elements? Yes?
Wait.
I can't hear you. Can you try to speak up? What are the elements? Yes, what's the first element?
1.
Is 1 a prime number?
I'm confused. Like, I've forgotten.
You've forgotten prime numbers. Can you call upon somebody?
Yes.
Ochailab? Ochailab, can you tell us? Can you tell us the elements of set P? Ochailab is always quiet. I'm wondering if he's always in class. Yes, Luswata, tell us what are those elements?
2, 3, 5, 7.
7. These are the prime numbers. These are the prime numbers less than 10. Because you can't include 9, 9 is not a prime number. So for the sake of Jerome, prime numbers are those numbers with only 2 factors, 1 and itself. So what makes 1 not to be a prime number? 1 has only 1 factor itself. It has only 1. So it doesn't have 2 factors. We're saying a prime number is a number with 2 factors, only 1 and itself. You notice that if you look at for the factors of 2, 1 and 2, factors of 3, 1 and 3, factors of 5, 1 and 5, factors of 7, 1 and 7. 9 is not a prime number because it has 3. 1, 3, 9. So that one doesn't have 2 factors. That's how we define that. Then the other one, set T is a set of triangular numbers. What are triangular numbers? Can somebody tell us those triangular numbers? Who is this Trent? Trent AA, can you tell us what triangular numbers are? Triangular numbers less than 20. Trent, can you tell us those triangular numbers? Trent? Okay, let's go to Mugabe. Mugabe Elijah, mute yourself, please, so that we don't have a data video. We want a clean video to be shared. So, Mugabe Elijah, tell us what a triangular, what does set T, the elements of set P, I mean set T. Brent, mute yourself. If you're not muted, mute yourself. So what are the triangular numbers? Can somebody tell us the elements of this set T? These are the things we learned in senior 1. Yes, Ruswata.
1, 3, 6, 10, 15.
15. How are you getting these elements? Can you tell us how they are obtained?
I cannot explain it properly. Like for how to get 3, I add 1 plus 2, which is 3. For 6, 1 plus 2 plus 3 plus 4. Then
so you're
for
simply adding consecutive counting numbers. You add consecutive counting numbers to come up with triangular numbers. For instance, the first one is 1. That's the first triangular number. Then the second one is 1 plus 2. The other one will be 1 plus 2 plus 3. Another one will be 1 plus 2 plus 3 plus 4. Another one, 1 plus 2 plus 3 plus 4 plus 6. I mean plus 5. That's how we generate triangular numbers. You know, plus 3, Now, if you understand your sets very well, you know, you understand sets, you've read your work, and you know you're going for an exam, you know all things about sets. Then they bring something like this. You'll even fail to start if you don't know what triangular numbers are, if you don't know what prime numbers are. So while preparing for exams and you're reading sets, also know types of numbers. So this is the first triangular number, it is 1, the second one is 3, this one is 6, this one is 10, this one is 15, this one will be 21, but now they said those ones less than 20, that's why we stopped, that's why he gave us up to 15. They said less than 20. So we've generated our two sets. We have set P and set T. They're saying find the number of P union T, the number of elements in set P union T. Now we first need to get the elements of set P. What are the elements of set P union T? What are the elements in that set? So P union T will have, can somebody tell me the elements of this set? Jethro, tell us the elements of that set. What are the elements in set P union T? Let's be faster so that we don't spend a lot of time online doing little work. Jethro, what are the elements in that set?
Which set again?
P union
T.
T. P union T, what are the elements in that set?
P union T. Wait, I'm not seeing it.
P is here, T is here. We are looking for the elements of P union T.
So 1, 2, 3, 5, 3, 5, 6, 7, 10, and 15.
10 and 15. Those are the elements of set P union T. Those are the elements. So what's the number of those elements? How many elements in that set?
1, 2, 3, 4, 5, 6, 7, 8.
8 elements. So you'll have answered this. And this is a section A type question. It is for 4 marks. This will be 4 marks in section A. Okay. Number 6. Let's move very fast because we're just recording 2 sets. You looked at 2 sets in senior 2. So we don't want to dwell on this so much as we're finding some concepts that are giving you hard time. But we looked at this in Form 2. The other question is here. They're saying, given that the number of elements in set A complement is 8, and the number of elements in set B complement is 13, then the number of elements in A intersection B is 5, and the number of elements in inverse set are 24. Represent the above information on a Venn diagram. So our Venn diagram here, we are dealing with 2 sets. Something like that. So our universal set, I can instead use shapes if that is not coming out well. I can use shapes like this. Then I insert another shape inside. And the challenge with using these shapes is you over navigate around and the thing freezes. Shape. Okay, it has come. So we need a set. This will be set. This will be one of the sets. That's what we have. So the universal set, this is our universal set, and the number of elements in it, they're saying there are 24. Then what else? We have, of course, set A and set B. That's what we have. Now, what have they given us? What do we know? We know that the number of elements in A intersection B, this is the area of A intersection B, there are 5 elements here. What else do we know? We don't know the number of students who liked A only, so we can call it. The other time I used unknowns and somebody was asking, why do we use unknowns? Because we don't know them. So here we don't know this one, we can simply say this is A. We don't know the number of elements who liked A only. Yeah? We also don't know the number of elements who liked B only. And finally, we don't know the number of elements who liked none of. None of the two, neither of the two. Neither A nor B. So something like this. We don't know the number of elements. That's our Venn diagram. That's what it will look like. Now, answering the questions, they want us to find, find number of A union B complement. They want you to find X because X is the one that is standing for the number of A union B complement. Now here would have used the very set notation. Would have also said this is A intersection B complement. Then this is A complement intersection B. And here we say this is A union B complement. And we use this in our calculation. But now writing this all the time, any like that will become very hectic for you to write. That's why we choose to choose symbols that are very easy for us to write, then later on relate to what we're looking for. Now here, we are letting it to be A because writing this will take us a lot of time. Here we're letting it to be B because writing this will take us a lot of time. But if you're comfortable with that, you can choose to write that if that's the easiest for you. Now here, we need to find what the value of A is. We need to find what the value of B is. And we also need to find the value of X. But according to the information given, they're saying the number of, yes, Trent, you raise your hand. Trent, your hand is up. So now here, if they said the number of A complement is 8, which region represents A complement? Let me shade that region. Shading the region A complement. That means A complement is outside A. So all this part here is outside A. All this is outside A. All that is outside A. You can see. All this area is outside A, like that. And they're saying the number of elements in A complement is 8. So what constitutes that set? They're saying the number of A complement is equals to 8. So how many are in that element, in that set? A, we have B. B is in that region, A complement, and X is in that region, A complement. So that means that 8 will be the same as B plus X. That's what we have. So our first equation will be B plus X is equals to 8. That's what we have. And we can't do anything about this. We can call it equation 1. Then the other information they're also telling us, they're saying that B complement is 13. We need to shade that region B complement. What is in that region B complement? What is in that region B complement? Let's shade that region and we see what is in that region. What is in the region B complement? B complement means you're outside B. Outside B, this is all outside B. This is all outside B. This is all outside B. This is all outside. All this is outside B. You can see the region represented by purple is a region outside B. So what is in that region? Let's see. They're saying number of elements in B complement, there are 13. And what is in 13? We know that A is outside. A is here. It is outside. then plus x is also outside, is in the region B complex. So I have something like this. So that means that my second equation is a plus x equals to 13. That's what I have as my second equation. That's what I have. So you see, we still have more unknowns. We have 3 unknowns. We have a, b, and x. You can never solve such an equation. If you have 2 equations, I think you learned how to solve simultaneous equations. You can never solve 2 equations when you have 3 unknowns. So what you have to do is we have to look for another equation. How will you get the other equation? You come to the universal set. They are saying elements, all elements in the universal set add up to 24. So you can add up everything here and equate to 24. Everything inside this rectangle should give us 24. So that's how we're going to generate the third equation. From the universal set, they are saying the universal set is equals to 24. The elements in the universal set, what are those elements? That means that we shall have A, which is inside the rectangle, so plus 5, which is inside the rectangle, plus B, which is inside, then plus X. All this should give us 24. So from here I'll have A plus 5 plus B plus X is equals to 24, like that. Then from this, I'll have A plus B plus X equals to 24 minus 5. Then I finally end up with A plus B plus X equals to 24 minus 5. What do you get? I think
19.
So this is our third equation. Who can tell us how now how can we solve these 3 equations? How can we solve these 3 equations? Can somebody tell us what we can do? We have 3 equations, we have 3 unknowns. It can be solved. We can solve these equations. Now, how can we solve this to find the value of x, the value of a, and the value of b? Can somebody tell us how this is done? Olusaga, you have any idea how we can solve these equations, come up with the unknowns we're looking for, the unknowns we created? Okay, it's like nobody has an idea. Let's do it here. Now, that's why we chose to use A, B, and imagine if we're writing here where B is, we're writing A complement intersection B. Where X is, we're putting A union B. It would be, everything would be looking untidy here. So that's why we choose to use simpler unknowns. Now, what we can do, you notice that there's A here, there's B here, and then there's X. We can decide to express equation 3 in terms of one unknown. So we go to equation 1, make B the subject. I go to equation 2, make A the subject. I carry A, substitute here. I carry B, I substitute here. I'll have equation 3 in terms of one unknown, and that would be easy for me to solve. So I can say from equation 1, I say B is equals to 8 minus X. When I take X, when I take this one this way, it becomes a minus. That's from equation 1. Then I also say from equation 2, hope you're seeing what I'm writing. From equation 2, are you seeing all these are very small things? Are you seeing what I'm writing here? Hello?
Yes, I see.
Okay. So from equation 2, we also take this one, this side. We take the X on this side. We shall have A equals to 13 minus X. Then what we do, substitute. We substitute A and B in equation 3. In equation 3. So where there is A, I'm going to put 13 minus x. Where there is B, I put 8 minus x. So I'll say A is 13 minus x because my equation 3 is A plus B plus x equals to 19. Now what I'm saying in simple terms. We carry this one here, the whole of these, we come and put it here, where there is B here. Then we also carry the whole of these, come and put it where there is A here. So we shall have, our equation will be, we shall have 13 minus x. The whole of this is standing for A. Then plus, the whole of B is 8 minus x. Then plus x equals to 19, something like that, equals to 19. Now, of course, this x and this one will cancel. We shall be left with 13 plus 8. 13 plus 8 gives us 21 minus x equals to 19. Then from here, what do I do? What do we do next? Can somebody tell us what we can do next there? We have 21 minus x equals to 19. How do we find x now? What do we do? Solomon?
Well, there are two options. We can either choose to move x to the place of 19 or we move 21.
Okay. So let's choose one. Let's move x the other side and 19 comes this way. So we shall have 21 equals to 19 plus x. That means this x has crossed equal signs and the sign has become positive. So we shall have that. Then also the 19 crosses this way and the sign becomes negative. This is positive this side. When crosses equal signs becomes negative. So 21 minus 19 will be the same as x. So 3 will be equals to x. So therefore, we can now conclude that our x is 3. But then they didn't ask us to find x anywhere. Our question has no x anywhere whatsoever. What is x representing in our Venn diagram? X is representing the number of A union B complement. I remember we defined these regions in our introduction. We defined these regions very well. So this is the same as 3, and that's what they wanted. That's what your part B was asking for. Do you have any questions there? Do we have some questions? If you've just joined, you mute yourself so that you don't have the noise.
Excuse me, sir.
Yes.
May you repeat?
Sorry?
May you repeat?
I repeat from what point?
Point of substitution.
From the point of substitution. Here we are putting A. This point here. Okay, so just maybe to go over it, we have a question where they have given us, instead of giving us the number of those who like maybe A, they have given us those who did not like A. And they've also given us the ones who did not like B. From here, you can see this if I can highlight. Oh, sorry, what have I done? Did I stop screen share? Okay, this is what I've shared. Okay, so I was trying to emphasize something here. Look at this. Look at this. What they have given us here. And what they have given us here, this information. Now, this information, unlike most of the questions that you're used to, it's a bit different. Instead of giving us number of B, they have given us number of B complement. Instead of giving us number of A, they have given us number of A complement. So, according to our Venn diagram, when you draw the Venn diagram here, you put, we don't know those who liked A only. If they had given us a number of A, we would have said now this is maybe we could have said this is maybe 8 minus x, or 8 minus 5, or this one be 13 minus 5. But what they gave us is those who did not like who did not like A, those of A complement. So that's why we're letting A to be unknown, our unknown here representing those who liked A only, and B representing those who like B only. So generating these equations, I think you don't have any challenge with these equations here when you're generating them, because we say those of A complement is 8. And according to our Venn diagram, which region is represented by A complement? The one we shaded with the yellow color, that is outside A. Now outside A we have B in it, and we have X in it. That's why we're saying 8 is equals to B plus X. And we ended up with equation 1 like that. Then also for B complement outside B, the one we use purple color to shade. So anything out in that region will be in the region of B complement. So we have, that means that B complement will have A plus, B complement will have A plus X, and A plus X will give us the second equation. That's Roman number 2. Then we notice that we have, there's no way we can solve these two equations. Why? Because there are 3 unknowns in them. We have A, we have B, we have X. When you're doing math at any level and you come up with 2 equations, you come up with equations which are fewer than the number of unknowns, just it's not possible to solve those equations. There's no way you can solve Roman number 1 and Roman number 2 and find any unknown. It is not possible. So that's why we go ahead and look for which other equation can we create from the information given. We notice that we can use the universal set to come up with another equation. And what does the universal set say? If I have universal set, they give me the elements of the universal as 24. Universal gives us a total of everything in that in the parameters in question being considered. Now in this case, what is inside this rectangle gives us the universal set. So we add up everything inside this rectangle. We add up everything inside that rectangle, and we shall have A plus 5 plus B plus X. A plus 5 plus B plus X, giving us 24. And this gave us the third equation. Now that we have 3 equations and 3 unknowns, then it is very, very possible for us to solve these 3 equations simultaneously. You looked at simultaneous equations, I believe, but then in most cases you're looking at 2. In this case, we're presented with 3. So how do I solve this? I now go back, and there are many ways of solving this. I see A plus B plus X equals to 19. Now how can I remove this A? Because there are 3 unknowns. I have equation 1, it is in terms of A. I have equation 2, it is in terms of A. So what I do, I simply make A the subject. My endeavor is to have 1 unknown here. So how do I remove A and B? I make A the subject here in equation 2. I also make B the subject here in equation 1. And this is what we ended up with. By simply taking away X, it crosses equal signs. Taking away the X, it crosses equal signs. We have B equals 8 minus X. We have A equals 13 minus X. Then afterwards, we substitute them here, substitute them there. Where there is A, we put, where there is A, we put 8 minus X. Where there is B, we put 13 minus. Where there is A, we put 13 minus X. Where there is B, we put 8 minus X. Then plus X equals to 19. Then you solve for X, and that's what we end up with. They would have also asked you to find the value of B. You just come and put X here. Our X is 3. That means that B will be equals to 5 from this. And our A will be equals to 8 when you subtract 8, not 8, 10. When you subtract 3 from it. Do you have any question from there again? Any other question from this? Do you have any questions? The one who asks, have you understood it now? Hello? Hello? Somebody wants me to repeat this. Are we together now? Hello,
Yes, sir.
are you okay with it now?
No, it was it me who asked.
Okay. I don't know us has even kept quiet. So let's move on to another concept. Hope you've understood this. If you still have any question about it, you can ask. Loasa, you're on and off. I don't know whether it is the network or there's any other problem. Make sure you work on your network and stabilize. Number 7, the sets P and Q are such that number of elements in P are 10, number of elements in P complement intersection Q complement is 8, and the number of elements in P intersection Q complement is 7. Represent information on a Venn diagram. Hence, state the number of that. So I'm going to enable annotation and let somebody draw for us. Somebody tries to sketch for us here. One of you should sketch for us here the Venn diagram, and you see how it looks like. So I'm enabling annotation. So that somebody draws a Venn diagram in that space there. Only one person, not all of you. Let me see, allow participant wanted. Yes. So can maybe Solomon, you draw for us here a Venn diagram for this question. Just try to sketch for us and we see how it look like. Hey, why is the work jumping away? Just draw the 2 circles and you put for us there what. That's okay. Don't mind about even if it is not very perfect. We just want to get the information, even if the circles are not. That's fine. Just continue. We have 2 sets. So we need, we have set P. You can write P. 8 is outside. That's correct. That is P. It is fine. You can understand. Okay, you're again deleting it. That's okay. That is Q. This is P. Where is the 7? Yes, we can see it. Where is the 10? The 3 is in the center. The 3 in the center, that's correct. What are you putting outside there? We're not understood what you're putting on top around here. What's around here?
10. I'm trying to put 10.
We're trying to put 10. Okay, yeah, I can see P equals to 10. Then what about here? What is supposed to be there? What is that? 13?
No, n minus 3.
N minus 3. Yeah, of course, yeah, because you don't know it, so it's n minus 3. Then you sort of look for n. Okay, I think that's good. You can now remove it so that we can draw it together. Thank you. So we have, they are saying, represent the information in Venn diagram. We need to put a Venn diagram. Somebody has just been sharing with us a Venn diagram there. So let me put one here and we see. We insert those things the way they're supposed to be. I'm using a highlighter. Let me move it. Put a pen. That's our set of circle. our outline. So we have one of the sets, and this one has stopped here. Let me just remove it. This is one set. Then we have another one. Okay, that will be enough. So if this is our set P, did they give us the number of elements in P? Yes, this is our number of elements in P. They are 10. Our number of elements in Q, they are not, how many are they? Number of elements in Q are the same as those in, outside. You get this? Have you gotten this equation here? Number of elements in Q are the same as those. So that means that we have 8 outside here, and this is also the same as 8. You know, the number of elements in P, in P complement, intersection Q complement, are the same as those in Q. So if Q has 8, then this one also has 8. Remember, I told you that the region P union Q complement is the same as the region P complement intersection Q. We had an illustration at that time. This one, they like neither. Neither of the two here. Here they can say those who did not like P and Q. See, they didn't like the two of them. So we have this, the number of elements in P only, you can see here. This is P intersection Q complement, meaning number of elements in P only. There are 7. Now that means that if the whole P has 10 and 7 are here, that means we shall have 3 remaining here. And if you have 3 here, then that means that if all of this has 8, then this one have 5, like that. So they're saying, state the number of elements in P complement union Q. What are the number of elements in this set? P complement union Q. What are the number of elements in that? Can somebody tell us that? What are the number of elements in P complement union Q? Can somebody? Yes? How many elements are there in P complement union Q? Jerome Katsime, how can you get the number of elements in P complement union Q? So here, if you want,
13.
How many?
13.
How can you get other number? Like P complements element. Wait, number of P complement union Q is like the number of minus P, but with Q, like its number.
Yes, and now according to this diagram, what are those? What are the elements in this?
Technically 8, 5.
8 and 5. 5.
No, 5.
There are 5.
Yes.
Okay, let's try to investigate and see. We're going to investigate using this concept of shading unknown shading regions in set. We have something like this. I'm going to use, since I've used this, I'm going to use a different color. I'm going to use yellow and green. So let me have this. Now let's say this is our set. This is our set P, and this is our set Q. Now let me shade the region P complement. P complement would mean we're shading outside P. Outside P, this is our region P complement. P complement, like that. This is our region P complement. What is in that region according to our Venn diagram here? It is 5 and 8, isn't it? And so it is 5 and 8. Then we also shade the region Q, region Q. We're going to shade region Q. Region Q, because we're looking for P complement union Q, so I need to shade region Q. Let me use green. Region Q. Region Q, of course, it is inside this set. The whole of this is Q. Region Q is this one. Now, if they were asking for the region P complement intersection Q, we would take this region here, where we have the two shadings, where we have both green and yellow. This region, that will be the region P complement union intersection Q. Now, if it is union, we said if it is union, you state all the elements in the two sets, avoiding repetition. So any region that is shaded will represent P union Q. Do you get it? Hello?
Yes, sir.
Do we get it?
Yes.
Yes. So according to our diagram, our Venn diagram, we're going to state all elements that correspond to this region. The region that has been shaded, green and yellow. Any region that has been shaded represents P complement union Q. Now that means that according to this, we have 3, we have 5, we have 8. All these ones are in the region P complement union Q. Is that okay?
Yes.
So that means that our number of elements in P complement union Q will be equivalent to 3 plus 5 plus 8. And that gives us what? 16? Yes. So the elements in that set, there are 16 elements in them. So in most cases, when you're dealing with these sets, the concept of shading, if they ask you to shade, let me try to emphasize this more using another detailed example. Let me write it on the sides this way. That's not part of our main one. If I have a Venn diagram like this, I want now to emphasize this because these are the terms we are going to use in exams and most of you will be off. Let's say this is my set P and this is my set Q. We have elements A, B, 1, 2, C, D, E, G, H, like that. Can you help me state the elements of P complement? What are the elements in P complement?
There is C, D, E, G, and H.
G and H. Those are the elements in that set. Now, what are the elements in set Q?
C, D, E.
C, D, E. We also have 1, 2. They're also and they also in that set? 1,
Yeah.
2. Yeah,
2.
something like that. Now, if they ask you to state the elements of P complement union Q, you're going to look for the elements here and here. You write all of them, but avoid repetition since it is union. So I'll have which one is there? I'll have C, I'll have D, I'll have E, I'll have G, I'll have H, I'll have 1 and 2. You see? So these are the elements in that set. Now let's look at this. Let's look at our Venn diagram and you see where those elements are coming from. I see 1, 2. 1, 2 is here. I see C, D, E. C, D, E is here. I see G, H. G, H is here. So this is the region we're talking about in our question. If you look at what we're considering here, we're considering this all of this region, all it outside that. All outside that is the region for P complement union Q. And that's how we came up with that answer. So the knowledge of knowing how to shade the wanted regions on in sets is very, very important in helping you identify the regions that are being asked for. So lastly, I think this is the last question on 2 sets. They are saying, given that the number of elements in the universal set are 27, number of elements in A are 13, number of elements in B are 16, and number of elements in section that represent the information on the Venn diagram, then use it to determine that. I think we've done this several times. This is not a big deal. Let's also do this very fast. Insert a Venn diagram. Then I pick the two circles inside. Oh, I didn't press. I'm going to pick a circle. Come and put my circle here, like that. And I'm going to pick another one. Shape, circle. I have this one from here, like that. That's what I have. Now, what is I have set? They are talking about set A, the number of elements in set A. There are 27. It's always good to summarize this information. Good enough, you're lucky that all the questions you're looking at here are being summarized. They're not giving you questions in words, except, I don't know, the next, most of them, maybe number 4. Yes, that's the one that they had. But now when you're dealing with three sets, most of these questions will be in words. They'll give you those that information in words. You must know how to summarize, extract the information from the text given. That's what we're going to do. We're going to do around 10 questions on 3 sets. And trust me, by the end of the 10 questions, you'll have 3 sets at the back of your mind. This is 16. Intersection A, intersection B, they are saying there are 3. What else have they given us? That's all. They are saying those in A are that, this are that. So how many will be here? How many will be in A only? How many students are in set A only? Are they students even? Okay, elements. Yes. Solomon?
Yes, teacher.
How many elements are in set A only? We have the whole A has 27. The intersection takes 3. How many will be here?
24.
24, yeah. This will be, of course, 27 minus 3, which gives us 24, which is equals to 24. Yes, Jesse? Jesse, your hand is up.
Can you hear me?
Yes, I can hear you.
Yeah, according to your question, the number of elements in set A are 13, but up here I'm seeing that you put 27.
Oh yeah, I think that's a mistake. That is a mistake. Thanks for the observation. This is not 27, it's 13. Yes, this is 13. So this is 13, and that means that here we shall have 13 minus 3, which gives us 10. 13 minus 3, which gives us 10. Because the whole set has 13 elements. But of those 13, 3 also belong to belong to part B. So to get those who liked A only, they are 10. Because now if I add the total here, it must give me 13. Then here the 16 minus 3, and that should give me 13 here. What about outside? Given that number of that is that, number of that is that, number of that is that, and that is that. We've utilized all that. Represent information on the Venn diagram. we've represented it and determine Roman number 1, those who do not like anything. So we put here something. Let what is here be x, something like that. So they want us to find the number of elements that liked neither A nor B, or that did not like A and did not like B. So what we do here is we know that everything under the Venn diagram, when you add everything in the Venn diagram, it must give us the inversal. So 10 plus 3 plus 13 plus x must give us 27. So from here, this is 23, 26. 26 plus x equals 27. So from here, you can see that x equals to 27 minus 26. So x becomes 1, like that. Is that clear? Jethro? The people are not communicating here. I don't know whether they're in class. Jethro, Chailab. Then I can see their names here, but I don't hear anything from them. Okay. So that's how we're supposed to do that. And that's all about 2 sets. You'll find this very often. 2 sets are very common in section A. You'll find them very often in the question bank if you have one. You can peruse through and see most of these questions. 2 sets will be in section A for 2 marks. 4 marks. Then 3 sets are mostly common in section B for 12 marks, and they are always there. You can never find a year where sets have not been have not been set. Most of the years, at least, it will be there. Now, I want us to slightly talk about 3 sets, then we introduce it. Since the number is not big, I don't want to talk too much about it, then next time I again repeat. So I'm going to introduce it, and then we go into details of it in the next lesson. So we want to look at 3 sets. But if you have any question about 2 sets, you can ask and we work on it. Do you have any problem with 2 sets? If you do, you bring it forth and we discuss it. But for now, I'm introducing 3 sets. Problems involving 3 sets. Now, once you understand, yes, please.
Teacher, I have a question. Is A union B into brackets complement the same as A? No, the same as A complement union B complement.
Somebody is saying we can best understand those terms when we're shading unwanted regions. Shading regions of what? The set. You're saying is A union B complement
into bracket
like that?
Yes.
The same as
A complement union B.
Union B like this?
Yes. Is it the same?
Union B just like this?
Complement again also.
They are not.
They're not.
They're not. Let's get it from here. Let me just do something small for you here and you see. We're going to shade the region A union B complement and also shade the region A complement union B, and you'll see what the two how the two differ. Now, if this is my set A, this is my set B. Let's say we have elements A, B, C, here 1, 2, maybe D, E, F, G, H, like we had in the previous case. Now, I want us to state the elements. Can we state the elements of A union B complement? Or let's first shade the region. Let's shade the region A union B complement. A union B are these circles. So A union B complement, you shade outside the circles. You shade this. This is A union B complement. You see that? That's our region, A union B complement. And even when you state the elements of A union B complement, elements of A union B complement will be, what will those elements be? Somebody ask the question, please. Let's answer it together. A union B complement. What do those elements be?
G and H.
G and H. That's what we have. Now let's also shade the region. We shade the region A complement, union B complement. We have this, we have that. This is our A, this is our B. We still have our elements A, B, GH, GH. I mean, this is 1, 2, G, I mean B, E, F, GH, something like that. So let's shade the region A complement, union B complement. So I first shade the region A complement. Which one's my region A complement? I'm shading outside A. This is my region A complement. Like that. That is A complement. Which region is B complement? Let me choose yellow, 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 yes, yellow will work. My region B complement, I shade outside B. So if this is my B, this will be outside A. This will be outside B. All of this is outside B, outside B, outside B, outside B, outside B, outside B, like that. Like this. So you tell me the elements. What are the elements of A complement? What are those elements? From what we shaded here. Elements of A complement will be
1
will be
1.
You don't have Y. It is B.
1.
Sorry?
1, 2.
No. 1 is not in A complement. This is still in A. You see that this is still the circle of A. So we want
Yes,
outside.
D, E, F.
D, E, F.
G, H.
H. Those are the elements of A complement. What are the elements of B complement? B complement?
A, B.
A, B.
G, H.
G, H. Now, if they wanted to find A complement union B, we're going to set all the elements in A and all elements in B, but avoiding repetition. So my elements in A complement union B complement B, A, B, A, B, D, E, F, G, H. Do you see that? So where are these elements found? Where we've shaded, you see that where we have yellow and green. Yellow is here. Any region that has been shaded represents A union B, A complement union B. This is the region, this is the region, this is the region, that's the region. So are the two sets the same? No. A union B complement it is just outside the two sets. A complement union B complement enters even and takes A only. It takes A only and also includes B only. So it is outside then plus that. The two are not the same. You get it?
So teacher, you leave out the intersection.
What about the intersection?
Yes, you leave it out.
Yeah, the intersection is left out. It is left out. You see that according to the shading, it has been left out. The intersection is in the middle here, it has not been included. Now, what you should know is the region A complement union B complement is equivalent to the region A intersection B complement. You see that? Because according to your question, you're saying we leave out, you see that we're taking all the elements but leaving out intersection. If they ask you to state the elements of A intersection B complement, you will state all the elements except the ones in the center here. You get it? You state all the elements except those at the center here. So that means that A complement is just like the same as A complement union B complement. The elements will be the same.
Okay.
Because if they ask you to shade, if you have two sets like this, and ask you to shade the region A intersection B complement, which region will you shade? Of course, you shade everything. You shade everything but leaving the center. And you notice that even here we've shaded everything and left only the center. We've shaded everything but left only the center. So A intersection B complement the same as A complement union B complement. Those two are the same. And also A complement intersection B complement is the same as A union B complement, like that. I think you get the difference. These two are not the same. This one saying A complement union B complement. This one saying A complement intersection. You see, notice that the symbols joining them are not the same, and even here they're not the same. So we've seen this already. We've been using even this from the previous examples. We used that somewhere. I'm moving up and down. Yeah, so these terms ought to be known because they are going to use them. Now, like this x here is the same as A complement intersection B complement. And it's also the same as writing A union B complement. The two are the same. Because intersection, now like in this shading here, intersection means the yellow and the green are in that region. A complement is meeting with B complement. Now, according to the shadings here, green is meeting with the yellow. And where are they meeting? They are meeting outside only. That's why we have both green and yellow. Here we have yellow only. Here we have green only. But outside we have the two of them. So here the intersecting A complement is intersecting with B complement. But also, we know that the same thing is the same as saying that region is also the same as saying A union B complement. Because if they give you a Venn diagram like this, they give you a Venn diagram like that, and they ask you to shade the region A complement, I mean A union B complement. A union B is inside here. So A union B complement will be outside, something like that. Will be outside there. So you need to practice the concept of shading the unwanted region for you to understand these terms in details. So I'm going to slightly talk about three sets, just introducing it. We shall not do any serious work about it. So that next time we pick up from there. We're just going to introduce the concept. With the fact that the number is small, I don't know why. People, I think, were impatient when we had. Okay. So we have one set. This is one set. We're dealing with three sets. So three sets compare. It always compare three issues, three events. Maybe you have subjects, maybe physics, math, and English, or you have sports. Maybe people support to play volleyball, netball, and football. It relates three sets will always relate three things. This will not come out well. Okay, let's just have something like that. As long as the three sets are intersecting, that's what we want. So the universal set will be here. This is our universal. Let's say we're dealing with set A, set B, and set C. That's what we're dealing with. Now we're going to just define these regions. We want to know what each region represents. So I may call them, let me call them maybe region 1, 2, 3, or you can call them region A, B, C, D, E, F. Which one do you prefer? We use letters or numbers?
Numbers.
Numbers. Let's have this as region 1, this is region 2, this is region 3, this is region 4, this is region 5, region 6, region 7, region 8. But numbers are not. We may end up adding them yet. Let's deal with AB. I think because we may end up adding the numbers again. So we say this is A, this is B, this is C, this is D, this is E, F, G, and H. We have those regions. Now, what does region A represent? Region A, we're going to define region A in terms of set notations and also in statement form. What does region A represent? This region A, we're saying it is A only. When they say A only, those who liked A only, maybe if it is food, maybe it is maybe something, football, those who liked A only, that's what A is representing, A only. Or we can write it in set notation as, this can be written in set notation as, let me see, let me first remove this. We start with what the question will give you. Because in sets, they just use, people say number on sets are a bit hard, but they just use logic. It's just like filling a puzzle, something like that. Sets, when you're going for set number, just not going to be something related to logic, not filling up missing parts and all that. For those, some of you fill puzzles. There is Sudoku. I don't know how many of you play Sudoku in New Vision. Then there is those puzzles there. That's what sets are almost all about, filling up the missing gaps. So we have the region of A only. A only will be the same as region A. It is region A that represents that. Then in set notation, we write that can be written as A intersection B complement intersection C complement. That's how we can write that region A. So the question can say, find the number of students who liked A only. They wanted to find that value of A. Or they can say, find the number of students, or they can simply say, find N into A intersection B complement and C complement. Or find the number of students who liked A, but not C and B. They liked A, but not B and C, so they liked A only, something like that. So those are the terms you'll find in the question. They can say A, but not B and C. That's what they're trying to mean here. Then another one, that's the first thing you're going to find. Of course, we also have one for B only, which is also defined the same way. B only, that means that you're dealing with C. C is representing B only and can also be written as A complement intersection B intersection C complement. There you're dealing also with B only. You can also write it the same way. B but not A and C. Then also the same thing applies to C only. How many students like C only? C only, that means that you have G. And if you're dealing with G, that means that you have A complement intersection B complement intersection C. And in the same way, you can say C, but not A and B. These are the questions you're going to find. If you have a question bank, you open and you'll find these things I'm talking about there. Then the other one, number 4, they can say A and B. If they say A and B, and they just stop there, which region has A and B? Remember, in intersection, in set language, and means intersection. So when they say A and B, which region has A and B? It is this one here. The whole of this is A and B. This is A and B. So what do? A and B has B plus D. So A and B will be the same as B and D, B plus D. You just add B plus D. That's why I never wanted us to use numbers, because some of you are going to add and you get, when I say 4 plus 3, you're going to add up and get 7. Yet we're just using them to define regions. So B plus D, that gives us A and B. And that will be the same as that in set language, you shall say A intersection B. As simple as that. A intersection B. Okay. And of course here they also say A and B, just like that. A and B. Then, or both A and B, something like that. Then the next part, next one is, of course, the same thing applies to B and C. B and C. B and C, you look for the intersection of the two. A moment. Okay, so B and C, you go and look for the region combining B and C. This is my set B, this is my set C. So B and C, we shall take this, B and C, that will be D and F, and the intersection, intersection of B and C. So you say that will have D and F, D plus F. And that's the same as B intersection C. Then, of course, lastly, we shall have we have A and C, A and C, A and C. You also come and look in your Venn diagram. Where is A and C? A and C will be this. That is D plus E. D plus E. A intersection C. Then the other term that is very close to this one, 5. They can say A and B only. When they add only, that means it's different from A and B just. A and B only is different from A and B just. What do they mean when they want you to find A and B? Who can tell us what that one means if they say A and B only? We know what A and B is. A and B is B plus D. But if they say A and B, A and B only, what do they mean? Can somebody tell us what that one means? Guang, what does that mean?
I'm not sure.
You're not sure. So you look at this region, the region combining A and B. This is the region combining A and B. But note that in this A and B, there's also some part of C. You get it? This part here, let me use another highlighter. This part here has some bit of C in it. Which highlighter can work here? This one. Okay. This part here has some C in it. So when they say they want A and B only, they want you to exclude C totally. When they said A and B, we took the whole of this. A and B, the whole of this is taken. But when they say A and B only, A and B but not C, that means that you're eliminating everything related to C. So even this part will be removed, we shall be left with B only, which is we take only B. You see it? So when they say A and B only, that means that you remove anything related to C. Remember we're saying A and B is B plus D, but now it becomes B. It becomes B. And in its set notation, we write this as A intersection B intersection C complement. We have removed anything related to C. So that's how we write it. A and B, but not C. That's how we write it in words, in a statement form. A and B, but not C. That's why you see the complement on C. This complement is saying, but not C. And the same applies to number 6. We're just defining these regions and we end there. We shall pick up from there next time. When they say B and C, but not A, or we can say, let's first write this as B and C only. B and C only. Also come to the region of B and C. B and C is this. This is B and C. But I want B and C only. So I remove this other part of A. I eliminate everything because this B and C has some portion of A. The whole set of A is this one. It is also extending into B and C. So we remove everything and remain with F. So B and C only will have F. And writing it in set notation to be A complement intersection B intersection C. In words we say B and C, but not A. Something like that. And lastly, part 7, they can say A and C only, A and C only. This will be the same as we have A and C as D plus E. So we remove it, it just becomes E only because D has some element of B in it. Our D is supposed to be here. So D has some element of F in it. We eliminate it totally. Our D is at this point. D is inside here. So when they say A and C, we take D plus E. But when they say A and C only, you eliminate that part of B in it and remain with A and C only, which will be this E there. So that becomes E. And in mathematics notation, we can say this is the same as A intersection B complement intersection C. Intersection C, we remove B. And this is what we call A and C, but not B, something like that. Yeah, so that's all about intersections. Then the other one maybe is when they say, when they can say like that we've been defining in two sets. They can also say part 8, A complement, okay, A complement intersection B complement intersection C complement. They like none of these ones, like none of the three. If they are subjects, none of the three subjects, none of the three events, none of the three games, none of, if they didn't like any of the games, this I'll write it A complement intersection B complement intersection C complement. And from two sets we also say that this is the same as, we can simply say A union B union C complement outside. This is the same thing, and this will be the same as none of the three events. These events can be maybe games, can be, so they can be subjects, they can be foods, something like that. They didn't like any of them. And which region is that according to our Venn diagram? We've labeled it H. It is H. So those ones like none of the three games. There are other questions they can generate from this. They can say those who liked only one event. If there are subjects, maybe only one subject. How many students liked only one subject? Now you see that we have A, these ones liked only A, C liked only B, and G liked only C. So those who liked only one event are A plus C plus G. Those who liked only two are B plus E plus F. Those who liked all of them, they are D. So they can generate very many other questions. So next time, we shall put in more time again to make sure we understand the regions of a Venn diagram of 3 sets. Venn diagram of 3 sets, we shall again put in more time. Once we understand it, then it will be very easy for us to do questions, and I'm sure we shall understand them. We have some questions. Any questions before I end the meeting? Hello? Like I said, this has been recorded. I'm going to share it with you on, I'm going to put it on my YouTube channel. We'll pick it from there. Somebody is joining at this moment when I'm ending the meeting. So the meeting has ended. If you don't have any question, then see you in the next lesson. Hope power will be stable next week, but we are also proposing to to change the date for the lesson.